begin. Question 2. As mentioned yesterday, this way of writing is an alternative way of writing functions. So this is effectively fx equals to a tangent bx. It's just a presentation difference only. So nothing to worry about. Now a and b are positive integers. They gave you a range of x. They also told us that fx is 0 when x is equal to pi over 2. Let's do the substitution straight away and see what we obtain. So 0 equals to a tangent b times of x. In this case, x is pi over 2. So we have a multiplied by tangent of an angle equals to 0. Something multiplied by something equals to 0, what does that imply about either of them? Now one of them must be 0, right? So we have a equals to 0. Is that possible? Can a be equal to 0? Let me read the question again. What did they say about a? A is a positive integer. So is 0 a positive integer? No, 0 is neither positive nor negative. So we cannot have a equals to 0. Since a is not equal to 0, therefore tangent b times pi over 2 must be equal to 0. Okay, so from here we conclude tangent b times pi over 2. So the tangent of this angle has to be equal to 0. So apparently tangent of an angle equals to 0. What must that angle be? How many answers are there? So in order to answer this question, graphs are very useful. Whenever you have trigo ratio, sine, cosine, tangent, the result is equal to 0 of an angle theta, or when it is equal to 1, or when it is equal to negative 1. When you have these cases, sketch graph. Because the answer will be evident. It's going to be very clear once you sketch the graph. Okay? So now we have tangent of an angle equals to 0. I'm going to sketch the graph of tangent theta. Tangent of an angle, which we should be very familiar already. So as always, we divide the right hand side into 4 parts. This is in radian. So the middle will be pi. We divide it into pi over 2. Parts of pi over 2. Okay? So pi over 2, pi, 3 pi over 2, and 2 pi. This is for the portion x greater than 0. Of course, on the other side, we can do the same thing. Okay, so negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. This is just to help us see what the angles will be that give us tangent of an angle equals to 0. So sketching your graph, asymptote. Be very careful, don't touch the asymptotes. So we know that the period of pi is actually tangent is actually pi. So within the range from 0 to pi, we have one complete cycle, and we duplicate whatever is from 0 to pi over to between pi and 2 pi. So we see a duplication between the range of 0 to 2 pi. We already have 2 cycles over here. Okay, now let us continue the pattern on the other side. So I'm just doing a recap on our tangent graph. So this is our tangent graph from the range of negative 2 pi to 2 pi. I know this is way greater than the range that they requested for. But this is just to answer this question. When is it that tangent of an angle equals to 0? Where are the angles? Over here, our horizontal axis is our angle. Let's call this theta. Let's call this y. At which value of theta do we have the y value equals to 0? How many points can you see from my graph over here? Where we have y equals to 0. Y equals to 0 0 is a horizontal line. We've got 1 point over here. Well, the angle could be negative 2 pi. The angle could be negative pi. Angle could be 0. Angle could be pi, could be 2 pi. And based on the pattern, we know that it's going to extend infinitely all the way to the right, infinitely all the way to the left. Okay? So let us use some of these values and we see whether we can identify the smallest possible value of b. Okay? So what we have just concluded is that the angle, in this case, b times pi over 2, b times pi over 2 has to be 2 pi, negative 2 pi or 0 or pi or 2 pi. Let me just put them all down. B times pi over 2 has to be negative 2 pi, negative pi, 0, pi, 2 pi, so on and so forth. Again, I've got so many answers, but they only want the smallest possible value of b. So let's go ahead and solve for b. We get b by dividing all the values on the right by pi over 2. So we multiply by 2 divided by pi. Multiply by 2 divided by pi, we get negative 4. Or, okay, let me just put a comma. The next value, multiply by 2 divided by pi, I get negative 2. 0, 2, 4. So we see that b has many values. And we can see this number pattern. It is just going to be multiples of 2 in both directions. And now comes the restriction. Find the smallest possible value of b. Given that b is a positive integer. So based on this, what is the value of b? 2. That's it. So is it possible to do all this really quickly? Yes. As long as you have the shape of your tangent graph in your mind. You know it is going to be either 0, pi, 2 pi, negative pi, or negative 2 pi. All you need is just a bit of manipulation and you'll be able to get b equals to 2. That is why this is worth only 1 mark. Okay? Now, let's move on. For the next part, part 2. They tell us to use the value of b, which is 2. And given the gradient of the graph y equals to fx is 12 at a particular point. Sounds like we need to do some differentiation. So y is equals to a tangent 2x. Gradient of this graph. So we're going to dy dx. We're going to differentiate y with respect to x. So dy over dx is equals to a. We copy down the coefficient. Differentiate tangent. You get secant squared. Copy down the angle inside. We have just completed differentiating the trigo function. But we're not done yet. According to the chain rule, we work from outside to inside. So we have done the trigo ratio. Now we are going to differentiate the angle. The angle is 2x. Differentiating the angle will give us 2. So this is my gradient function for y. Based on this, let us substitute. The gradient is 12 when x is pi over 8. One equation, one unknown. I'm sure we can solve it. So 12, that is the gradient, equals to 8. Now secant square, can you get secant square first? 2 times of the angle, pi over 8. And all this is multiplied by 2. Okay? Do some manipulation. 2 times 8. Now secant square is actually 1 over cosine square. So 1 over cosine square pi over 4. And this is supposed to be equal to 12. Use your calculator, find out the value of cosine pi over 4, and then we're going to square it. So pi radian divided by 4, cosine of that value, square it. 1 divided by that value, you get 2. So 12 equals to 2a multiplied by 2. Therefore, A must be equal to 3. So we now have completed part 2. A is equals to 3. Part 3, to sketch the graph. I'm going to erase this first. Our job is to sketch the graph of y equals to 3 tangent 2x. Let me reintroduce you the graph of y equals to tangent A tangent x. Okay, so here we have in black y equals to tangent x. What does the graph of y, how does the graph of y equals to 2 tangent x compare with this? Okay, I've got a graph in black, y equals to tangent x. Now I want the blue graph. Y equals to 2 tangent x. How are they different? Equation wise, how are they different? Just a 2 times, isn't it? Whatever value I get for tangent x, that is the y value, I multiply by 2, I get my blue graph. So for every single x value, I multiply it by 2 to get the new y value. Which means, it starts from here. Suppose this is my new x, this is my x coordinate. This is my y coordinate for the black graph, for y equals to tangent x. We multiply by 2. This is now going to be my new y coordinate for y equals to 2 tangent x. We do that the same for everything. So it's going to look like this. It is going to stretch up to the asymptote. This is the blue graph. So how does the shape of the blue graph compare with the black graph? It is stretched vertically. Okay? This is the same concept for every single graph that you know with a coefficient that is greater than 1. A positive gradient, coefficient that is greater than 1. Okay, so it's applicable to your straight lines, applicable to your quadratic graph, and so on and so forth. So, if the question wants y equals to 3 tangent 2x, they did not ask for y equals to tangent x. Okay? Just one graph only. Can I say that this graph in black, I just relabel it. Same shape, I just relabel it. Oh, this is my graph of y equals to 3 tangent x. Is it reasonable for me to write this? Can I write this? Is this shape correct? Remember earlier on in black, this graph was y equals to tangent x. Then I show you that for y equals to 2 tangent x, it is actually stretched. So if I were to draw the graph of y equals to tangent x in black, as well as the graph of y equals to 2 tangent x in blue, on the same axis, I have to show a difference between these two graphs. One is stretched, or the other is not. But now, the question just wants y equals to tangent 3x. Okay, I don't talk about the 2 yet. Just y equals to 3 tangent x. Is it reasonable to say that it still has this shape?
Yeah.
Yes, it is.
No comparison.
Yeah, exactly. There's no comparison. Okay? So if this is the graph of y equals to 3 tangent x, then what does the graph of y equals to tangent x look like? Compressed. Right? Compressed. So if they ask you to draw this graph, as well as y equals to tangent x on the same axis, and you already fixed this, you already decided, oh, okay, this is going to be my y equals to 3 tangent x. Then the graph of y equals to tangent x has to look like this. It is going to be compressed. Okay, so this will be y equals to tangent x. Understand what I'm saying?
So essentially can bring French curve in this flow.
Can, but you shouldn't have to. It is just a sketch. Don't waste your time.
Okay.
Okay, so now we got the coefficient out of the way already. We know that it should look it has this shape. Y equals to 3 tangent x. But that's not what the question wants. They want 3 tangent 2x. So this over here is interpreted as we have 2 cycles of the tangent graph within the original period. What this means is that between 0 to pi, which is the original period for tangent, we now have 2 cycles. Okay, this 2 over here means 2 cycles within the original period from 0 to pi. That's one way of looking at it. The other way, just by pure memorizing the calculation, for this graph, period equals to original period. The original is pi. Okay, for tangent, original period is pi. We divide by this value. Okay, now we have the new period. It is pi over 2. Which means that from 0 to pi over 2, I have one complete cycle. Make sense? 0 to pi over 2, I have one complete cycle. Look at this black graph again. How many complete cycles do you see over here?
1.
You see 2, right? From 0 to pi, that's one cycle. Then it repeats from pi to 2 pi. Okay, so let me just remove all this. Now, for our new graph, for the graph that is required, the period is pi over 2. One cycle within 0 to pi over 2. So I'm too lazy to change my graph. Can I just change this pi to pi over 2? Would that solve the problem?
Yes.
Yes. Isn't it simpler? Okay, so now I have the graph of y equals to 3 tangent 2x. Okay, so this is my x value. This is my y value. But I only drew within the range of 0 to pi over 2. They wanted from negative pi over 2 to pi over 2. Can you tell what is going to be on the other side? Is it really a copy?
Yes.
Okay, yeah, it is a repeat of whatever is over here. Just repeat it on the other side. Okay?
So how the mark located
For the graph?
Yeah.
Okay, most likely, you get the correct period, you get 1 mark. You have the correct x-intercepts, you get 1 mark. The shape of the graph is correct, you get a final mark.
Okay.
Okay? Whenever we have graph questions that are sketching graph questions, significant points will get 1 mark. So significant points will be turning point, x-intercept, y-intercept. Our shape of the graph will be another mark. Then the last mark, depending on the type of question, what they want. Okay? So make sure you have all these correct. And of course, you must label also. Or your x and y axis, label them accordingly. Okay, so that is our 7 marks for question 2. Moving on to question 3. The expression a and b constants has a factor of x plus 2. Using our factor theorem, we let, okay, because it is convenient for us to write down f negative 2 equals to 0, right? Based on the question. X plus 2 is a factor, so f negative 2 equals to 0. However, the question didn't define what the function is. They didn't state what f is. So you have to let fx be equal to the expression 2x cubed plus ax plus b. Now that you have defined your fx, we can use this notation. F of negative 2 is 2 times of negative 8 plus a times negative 2 plus b. This has to be 0. Because it's a factor. So it has to be 0. Or if it is not a factor, then you will have a remainder. That is going to be the other value that we're going to write down. And we'll see in a short while. So let us simplify this. Negative 16 minus 2a plus b equals 0. We see one equation with two unknowns. The question wants you to find the value of a and b. At this point, are you expecting something already? You only have one equation with two unknowns. Are you expecting to have another equation with another two unknowns? Yeah, that is how we're going to solve for two unknowns. You need two equations. So it sounds like we're going to be doing simultaneous equation. All these should be going through our mind. So let us rewrite this. I know since I'm solving simultaneous equation, I like to use substitution. I'm going to straight away make b the subject. So b is 2a plus 16. This is equation number 1. Now I'm going to form my equation number 2 based on the remaining information. Remainder 35 divided by x minus 3. So f of 3, notice that when it is x minus 3, I substitute in 3. When it is x plus 2, I substitute in negative 2. Basically, whatever they are dividing by, equate it to be equal to 0. Then you will have the corresponding x value to substitute in. Okay, that's how it works. Huh? So do the substitution. 2 times of 27 plus a times 3 plus b equals to 35. According to the question. So 54 plus 3a plus b minus 35 equals to 0. Equation number 2. Two equations, two unknowns. Sub into 2. Try and find the most efficient way of presenting our work. So far I only have 5 lines. I'm going to be able to solve for a and b soon already by substituting it in. So now 54 minus 35, we get 19. 19 plus 3a plus, now I'm going to do the substitution, 2a plus 16 is 0. So from here, 5a is equals to negative 35. 5a equals to negative 35, a is negative 7. From here, sub into equation number 1. See, based on all our labeling, things get very efficient. No need, we have very minimal excessive writing. So substitute it back into equation number 1, we get b equals to 2 times negative 7 plus 16. So 16 minus 14, we get 2. So now we have the value of a and b. Okay, let me just write it down. A equals to negative 7 and b is 2. In part 2, using the two values, solve to x cubed blah 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 equals to 0. Okay, let's substitute. Okay, so 2x cubed plus, okay, not plus, it is negative, minus 7x plus 2 equals to 0. So now fx is equal to 0. How should we solve cubic equations? I don't have a formula. So,
divide.
okay, divide by what?
If there is a factor, then divide.
We divide by one of the factors. So in the question, they already gave you, oh, x plus 2 is a factor. So it makes sense for you to divide this by x plus 2. Okay, right now the power is 3. This is a cubic equation. If you factorize out a linear expression, which is x plus 2, what are you expecting as the result? Quadratic. Quadratic is power? Power 2. Okay, so you can go ahead and divide it this way. 2x cubed minus 7x plus 2, x plus 2, da 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 da. You will get a x squared term over here. That is one way to do it. The other way is by comparison. Okay, you have already correctly mentioned that when you divide this by x plus 2, we will get quadratic. So a is used, b is used. Let's continue with cx squared plus dx plus e. This is the general form of a quadratic expression. There will be an x squared term, there will be an x term, there will be a constant. Okay, we can maybe the d value is 0, maybe the e value is 0, maybe, we don't know. But I'm sure there will be an x squared term. Okay, so all this is equal to 0. Now let us find out the value of c, d and e without using long division. Okay, so these two have to be equal to each other. Are you able to tell, without calculation, the value of c? Very good. C equal to 2. How do you know it's equal to 2?
Something like something equals to 2x squared. That's like c.
Which term are you comparing? X cubed, x squared, x or constant?
X squared, x.
You want the value of c. So the easiest is to look at the x cubed term. How do we obtain an x cubed term? Only by taking x times x squared. Okay, so this is our only x cubed term. So cx cubed has to be equal to 2x cubed. Therefore c equals to 2. Okay, so from here, c equals to 2. Now the next easiest unknown that we can find out, what is it going to be? D or E? E. What are we going to compare to find the value of E? What are you going to compare? You want to compare the x cubed, the x or the constant? Constant, yes. Because the only way for us to obtain a constant through the many multiplication is if I take 2 times E. That's the only way I'm going to get a constant. So 2 times E equals to 2. What must E be? E must be 1. Now that I have my C and E, I'm left with D. Okay? At this point, you can substitute in values of x. X equals to 1, 2, 3, whatever it is, to find the value of D. Alternatively, we can start to compare the x term, or you can compare the x squared term. Okay? What is the x squared term? Is there any x squared term? No. Don't have. So what then must the coefficient of x squared be? Yes. The coefficient of x squared must be 0 in order for these two to be equal. So how am I going to obtain an x squared term from here? X times dx. Okay, that's one of it. So let me just write down here. X times dx, that is my x squared term. Is there any other x squared term that I can form? 2 times cx squared, which we already know c is equal to 2. So plus 2 times c x squared. These are the only two ways we can get an x squared term. No other way. Okay? And this has to be equal to how many x squared? This must be 0x squared. Okay, so simplify. We start to divide everything by x squared. It doesn't matter really. We are just interested in the coefficient. So here we are left with d plus 4 equals to 0. D must be negative 4. Okay, if you are familiar with this method, it can be really fast instead of doing a long division, which is fine also. Long division is just very computational. You're just like a machine doing the steps that we tell you to do. This one is more alive, it's more creative over here. It can be faster. Okay? So yes?
Sorry, for the remainder one, right, when you do long division, I remember you said something that if there's no x squared in the middle, right, you must leave a blank.
Yes, you must leave a blank space for the x squared so that your working remains neat. All the x cubed in one column, or the x squared in one column, x in one column, constant in one column.
But if I don't do it, it's not wrong, right?
If you don't do it, it's not wrong, provided you didn't miss out anything.
Okay.
Okay? Yeah, that's why, like what Kevin is saying, we should put a 0x squared to keep everything neat.
Okay.
Okay, so now I'm going to rewrite my fx to become x plus 2. C value is 2x squared minus 4x plus 1 equals to 0. So now, we are trying to solve this equation. They are only interested in non-integer roots. From here, this is cubic. I am expecting up to 3 solutions. So 3 roots, up to 3 roots. One of them is x equals to negative 2. But am I interested in this? No, the question doesn't want integer roots. They want something in this form. Okay, in a third form. So the other alternative is 2x squared minus 4x plus 1 equals to 0. Please do not try and factorize this. It will get you nowhere. They already gave you a clue. It is going to be a third. So we'll use our quadratic formula. X equals to minus b plus minus square root b squared minus 4ac over 2a. Now it is starting to look more like the form that they want. 4 plus minus 16 minus 8. That is square root 8 over 4. 4 plus minus square root 8 is 4 times 2. I am breaking up whatever is inside my square root into perfect square multiplied by something. So 4 is a perfect square. So this is 4 plus minus square root 4 is 2. Okay. Next step, divide by 2 throughout. 2 plus minus root 2 over 2. Next question. 5a. Solve the log question. Okay, I see that there's a base 3, and over here there's a base 27. It must click to you really quickly already. What are they trying to get you to do with the 27? Power. Okay, change of base. What base are you going to change it to? Base 3. Okay, 27 and 3, do they have a relationship? 3 power 3. All these must come to you quickly. So let's do some manipulation. Log base 3x equals to 4 plus, so you were saying change of base. You wanted it to be base 3. So it's going to be log base 3 something over log base 3 something else. Okay? So what I like to do is I visualize it this way. The number at the bottom, which is the base, goes down to the bottom. The number on top, in this case it is an x, goes to the top. That is the change of base. Are you happy to see this? You've got a log base 3x on the left hand side. You've got a log base 3x on the right hand side. You should be happy to see this. Because right now, you know there's a way to combine them together. As compared to the original format. Quite difficult. Okay, now, log base 327. As many of you have pointed out, 27 is the same as 3 power 3. It is much better to write it as 3 power 3 instead of 27. Okay? Because now we realize another thing. This power 3, what can I do with it? I break it down. Okay? So this particular 3 goes down this way. Then are you happy to see log base 3, 3? Why? It is equal to 1. Log base 3, 3 is equal to 1. So my denominator is simply 3. So this logarithm is now simplified to become an equivalent form of y equals to 4 plus y over 3. Don't tell me you cannot solve this kind of equation. Alright? And I'm just letting y be equals to log base 3x. Just to show you that this is linear. I'm sure you can solve this. Just treat our log base 3x as an unknown by itself first. Then find out why it is. Okay, so let us try that. From here, we're going to group the log base 3x terms together. So on the left hand side, I've got 1 of it. On the right hand side, I've got 1/3 of it. So I'm going to subtract 1/3 of it from both sides, leaving me with 2/3 of it. 2/3 of log base 3x equals to 4. Okay, I've got 1 of it on the left hand side, I've got 1/3 of it on the other side. So I subtract 1/3 from both sides, I'm left with 2/3 of it. Okay, now, if you are trying to solve for x, that means I want to get rid of everything. I just want to have x on the left hand side. Right now, there's a 2/3 attached to the logarithm. Let's get rid of it by multiplying by 3 and dividing by 2. Log base 3x multiplied by 3. 4 times 3 is 12. 12 divided by 2 is 6. Okay, 6. Now we just have a very basic logarithm. Then we have to change it back to the exponential form. The base over here is 3. So base 3. The logarithm is equal to 6. This is the power. Okay, in logarithms, we are trying to find the power most of the time. So the 6 over here refers to the power. And what is left must be x. 3 power 6. 729. Look at the number of steps. Just like this. 3 marks. Averill. Okay, next. 5b. The curve y equals to ax power n passes through these points. When a curve passes through the points, they are telling you that these are the x and y coordinates. So this is x2, y2. Whenever you get coordinates and equations, substitute them in. That's how graphs work. That's how you plot points. So let's substitute in the first set of coordinates. (40) equals to a 2 power n. Equation number 1. Again, 2 unknowns, right? One equation only. I'm sure I need another equation with 2 unknowns. That is found by substituting in the other set of coordinates. 135 equals to a times 3 power n. Equation number 2. To solve simultaneous equation, you can use elimination or substitution. What do you think is feasible over here? Elimination or substitution? Has to be substitution. So what do you want to make as the subject? You want to make A the subject or do you want to make N the subject? If you don't know what's elimination at this point, don't worry. Just use substitution forever. Okay? So here, it is easier to make A the subject as compared to N the subject. Because if you want to make N the subject, you use logarithms. Okay? A bit too troublesome. So from here, let us make A the subject. 40 over 2 power n. So you're going to sub, let's call this equation number 3. Sub into 2. Okay, so this is one way of doing it. The other way is to simply take equation number 1 divided by equation number 2 or equation number 2 divided by equation number 1. Because that way, the A is eliminated. Okay, but effectively it's going to be the same thing. So 135. Sorry? Yeah, you can look at it that way, it's fine. So 135 A. A is our 40 over 2 power n times 3 power n. Okay? So now, I want to get rid of this 40 over here. I want to group all my n terms together. Every time the n appears, I want to group them together. So I don't want this 40. I shall now divide both sides by 40. So 135 over 40 is the same as 3 power n over 2 power n. And your laws of indices tells you that this is 3 over 2 power n. We have gone through the derivation on why this is true. So you can just quote this. Okay, so 3 over 2 power n is equals to 135 over 40. Now 135 over 40 can be simplified to become 27 over 8. 3 over 2, power n is 27 over 8. Now stare at these numbers. Stare at the fraction on the right hand side. Does it look familiar? Compared to the fraction in the bracket, is there a relationship? What is the relationship? Q. So this can be rewritten as 3 over 2 power 3. What then is the value of n? By comparison, n must be equals to 3. So now we have found the value of n. We can find the value of a by substituting 240 or 3 135 together with n value into the original equation. Okay, so choose one of it. Let's choose the first set of coordinates, 2, 40. So substituting 240 and n equals to 3 back into the original equation. So y, which is 40, equals to a times 2 to the power of 3. 2 power 3 is 8. 8 times a is 40. A must be 5. The last unknown. There is another point 4 common k. So at this stage, we already have y equals to 5 x power 3. They are telling us for the x coordinate of 4, what is the corresponding y coordinate? So y equals to 5 times 4 power 3. 4 power 3 times 5. 320. Okay, 8 marks worth on the screen right here. Question 7. Okay, so proofs in plane geometry is not going to be examined at the end of this year. Okay, I'll leave this question to the last if we have time. But basically, even if proofs in plane geometry is in the syllabus, even if it is examined, part 3 is out of syllabus. Okay, it requires a certain theorem that has already been removed. So if that is your question, don't worry about it. It's not tested. Let me pause it first. Okay, class. Question 9. It shows part of the curve. Y equals to 3 sine x over 2. The line x equals to 4 pi over 3 meets the curve at P, x-axis at Q, tangent to curve, meets the x-axis at R. Find the length of QR. Okay, find the length of QR. We need a plan. How do we go about finding this length? What are some conditions that are set? What are some conditions that define this length QR? First, we've got the line x equals to 4 pi over 3. Next, we have this diagonal line. This diagonal line has another condition. It is a tangent to the curve. So it definitely has something to do with this curve of this equation. It is a tangent. So this gradient must be the gradient of y equals to 3 sine x over 2 at this point. X equals to 4 pi over 3. So now I know I can find the gradient of this diagonal line. Now, having this gradient might not be sufficient for us to find the horizontal length. So what will be useful is if I can have the equation of this line, then I substitute y equals to 0. Equation of this line can be found if I have the tangent, which I know I can get, plus one set of coordinates. Over here, we've got point P as the coordinate. But that requires me to substitute this value into y. So that is the approach. And that is the approach used by our answer key. But I have a shorter method, which I'll show you in a while. Okay? So let's start. some things are fixed already. I know I definitely need the gradient. So for y equals to 3 sine x over 2 dy dx. Three. Now our chain rule, we're going to differentiate from outside. So sine becomes cosine. Copy down the angle, differentiate the angle right now, we get half. Okay, so this is simplified to become 3 over 2 cosine x over 2. This is our gradient function. We want the gradient at x equals to 4 pi over 3. So dy dx when x equals to 4 pi over 3 is equals to 3 over 2 cosine 4 pi over 3 over 2. So this value is negative 3 over 4. The gradient of this straight line is negative 3 over 4. Okay, not much steps at the moment. Just differentiating only. Just finding the gradient at this point. Okay, here's the shortcut. Instead of finding the equation of this straight line, there is a method to find the length of QR, which means I answer part 1. By considering gradient of a straight line. Okay, what is the formula of gradient of a straight line? y2 minus y1 over x2 minus x1, right? Is there another version that you know? Rise over run. You see the right angle triangle over here? Right angle triangle. If you know the rise and you know the gradient, then you can find the run very easily, isn't it? And in this case, they want the run. So can we find the rise first? Yeah, the height. Can we find the height? You know how to find the height? You just stop x equals to 4 pi over 3 into the original trigo graph, right? Okay, let's do that first. When x equals to 4 pi over 3, y is 3 sine 4 pi over 3 over 2. Sorry, sine so my y coordinate for P is 3 root 3 over 2. Pi over 3 root. The laptop is getting quite hot, that's why it's going crazy. Okay, so I got a height. Now I want the length, the run. Let's equate them with our rise over run. It is sloping downwards. So the gradient is going to be 0, right? Rise is 3 root 3 over 2 divided by the run, which is QR. This is supposed to give me a negative value. Okay? So because it is sloping downwards, I put a minus sign. Make sense, right? Our rise over run. And this value has a gradient of negative 3 over 4. So from here, we just need to solve for QR. Punch everything into your calculator. QR is going to be 3 root 3 over 2 divided by 3 over 4. 3 root 3 divided by 2. 3 root 3 over 2 times 4 over 3. 2 root 3. Is that correct? Okay, 2 root 3 units. So here we have calculated it using the gradient, rise over run, without finding the actual equation of the straight line. Now part 2, area of the shaded region. Area of shaded region. We have to see that this is going to be divided into two portions. First is the area under the trigo graph, which we can find by integrating from 0 to 4 pi over 3. And then we add that to the area of a triangle. Please don't bother integrating this, just use half times base times height. Now the base we found in part 1, it is 2 root 3. The height is the y coordinate. So what we have to do over here is to just integrate. Really the work over here is just to integrate 3 sine x over 2. Okay, so area. Integrate 0 to 4 pi over 3. 3 sine x over 2 dx plus half times the base 2 root 3 times the height 3 root 3 over 2. Okay, from here on you should be able to do it yourself already. I will not go through the actual all the details. Because we have one last question. On circles. Circle, center C, diameter AB. A is the point, 1, 1, B is 7, 9. Find the coordinates of C. Find the center. Hey, if AB is the diameter, then center equals to the midpoint of AB, right? Therefore, the coordinates of C will be 1 plus 7 over 2, 1 plus 9 over 2, which is 1 plus 7, 8, so 4, 5. Guys, this is 2 marks. This is 2 marks, 4, 5. Next, to find the radius of the circle. Radius of a circle is half of the diameter. So you can calculate the diameter based on these 2 points. Then you divide it by 2. Or you can just take the distance from point A to the center. So radius equals to, so quote the formula, the distance x coordinate minus x coordinate. So 4 minus 1 is 3, 3 squared. Plus 4 squared. And we all know that this is 5. So here we have a total of 4 marks. Takes you less than 1 minute. Part 2, find the equation of a circle. Once you have the center, you have the radius. Writing the equation of a circle doesn't take you more than 3 seconds. Equation is x minus x coordinate, which is 4. You square it, plus y minus y coordinate. You square it, and this will be the square of the radius. Done. You can leave it in this way, you can choose to expand it, doesn't matter. Now next, part 3, show that the equation of the tangent to the circle at B is so on and so forth. Okay, so it is always useful for us to sketch. What exactly does the tangent to the circle at B look like? So let's say this is point B. We've got 7, 9. We've got a center, 4, 5, and a tangent line at B. To find the equation of a straight line, I need either 2 sets of coordinates or I need 1 set of coordinate plus gradient. Quite clearly, I have already 1 set of coordinates. And quite obviously, I cannot have another set of coordinates. That's all that's given. Therefore, I must be searching for the gradient. How do I find the gradient of this tangent line? So here we need to use our Emacs knowledge. What is the relationship between a tangent to a circle and the radius? They are 90 degrees. They are perpendicular to each other. Then we move back to our Emacs knowledge. What is the relationship between two gradients that are perpendicular to each other? Two gradients that are perpendicular to each other. What happens when you multiply them? You get -1. So from here, I know that I can find the gradient of the center to B, and with that I can find the gradient of this tangent line. Okay, so let's do that quickly. Gradient of BC, 9 minus 5, 7 minus 4. So you got 4/3. Therefore, gradient of the tangent must be equal to negative reciprocal. So negative flip. I've got a gradient of the tangent. I've got one set of coordinates. I can now write down the equation. Okay, so substitute 9 equals to gradient times x plus c. To find the y-intercept of c, multiply throughout by, just make c the subject. 9 plus 21/4. So we get 57/4. Therefore, the equation is y equals to -3/4 x plus 57/4. Now this is starting to look like what was required in the question. They didn't have fraction. Multiply throughout by 4 now. 4y plus 3x equals to 57. Shown. Next, part 4. Explain why point D lies on the x-axis. They give you a clue that the lowest point on the circle is D. If you have a circle, the lowest point must lie directly below the center. Okay, if you have a circle, the lowest point must lie directly below the center. We found out earlier that the center has coordinates 4, 5, which means that on the y-axis, this has a value of 5. The radius of the circle is 5. We found that out also. This distance is 5. Therefore, point D must lie on the x-axis. So go and phrase it in a way that the marker knows what you are trying to explain. Okay, so this is the concept. Now find the coordinates of the point where the tangents to the circle at point B and the tangent at D intersect. So basically, they want the x-intercept of this particular equation of the tangent. They want the x-intercept of this equation, which means y equals to 0. Sub y equals to 0, 3x equals to 57. X must be 57 divided by 3. That gives us 19. Yep, that's it. Finish.